This video gives you information about set theory and its separate sets. So let's get started. Hi friends, welcome back to maths classes. Today we are going to discuss a topic that's set theory. Now what is set, how the sets are, and what are the subsets or terms involved in sets and objects. Now first let's know about what is set. Set is a branch of mathematical logic where we learn sets and properties. A set is a collection of object or group of objects. These objects are often called as elements or members of set. It means set theory is a branch of mathematical logic where we learn sets and their properties. There are different sets for their properties, and a set is a collection of objects or group of objects. It means there is a set. If you will tell a set of bunch, a set of sticks, a set of stones, like that, it has a permanent or collection of objects, and these objects are often called as elements. These objects which are in the set are called as elements or members of this set. And for example, a group of players in cricket team is a set. It means there are some of the players in the cricket team. That cricket team is a set and the players are the objects or elements in the set. That's it. This is the main definition of set theory. That's set is a collection of group of objects. Now, representation of sets. Sets can be represented in two forms. That's roster form and tabular form, or set builder form. Now, roster form. A roster form are all elements of sets are listed and separated by commas and enclosed by curly brackets. It means the roster form is a form where if there is a set A is equals to one, comma 2, comma 3. This is the roster form where a set has some of the elements and which is enclosed with curly brackets and separated by commas. Here there is an example that a set of ovals, all ovals in English, it would describe the set as form as A is equals to A, E, I, O, U. This is the roster form. Next. Also, multiplicity is ignored while representing set. Multiplicity means if there is a letter, we can take, let's take as egg. Here, two are related. If they ask you to write the letters in the word egg, means we can write A is equals to E, comma G. That's it. Here G is repeated, so just we take an instead of 2 G's 1 G. Here there is another example that if a represent set contains all the letters in the word address, the proper roster form of representation would be L is equals to A D R E S. Here one D is removed and one S is removed for the set. And if it is like A D D R E S, if all letters are involved, then it is not a proper roster form. This is the proper roster form where no letters are repeated. That's it. Now let's go to set builder form. In set builder form, all elements have common property. This property is not applicable to the objects that does not belong to set. It means we take a common property from that set and we express it. This property is not applicable to objects which doesn't belong to set, and this property which we have taken the common property, that is not belongs to other which doesn't belong to set. Example, if set A has all elements which are neither even nor odd number, it is represented as S is equals to X is to X is neither even nor odd number. Here it indicates that X property, this sentence indicates about the X property, where X is symbolic representation used to describe the element. It is just a symbolic expression or representation. Here these two dots means such that, and this set means set of all. Next, another example, f is equals to p is to p single set of 2-digit perfect square numbers. It means f is 2-digit perfect square number. Here 2-digit perfect square numbers are 16, 25, 36, 49, 64, 81. If we take after 81, next it is 100, it becomes 3-digit, and before 16, if we take it is 9, again it becomes single digit. So these are the 2-digit perfect square numbers. And here we can see in the above example, 16 is square of 4, 5 square of 25, 36 square of 6, 49 is square of 7, and 64 is 8. Even though this 4, 9 and 121 are also perfect square, but they are not elements of set f. As I already told, that reason is it should be set of 2-digit perfect square numbers itself. It is limited to only 2-digit perfect squares. Next, types of set. There are many types of set, and these are the some types of sets. These are finite set. It means it has number of elements, or it is finite. Here if we take set of cricket players, we can tell it is an 11 members or 11 elements. And if it is like, if we take set of vowels, there are only 5 vowels, or set of consonants, only 21 consonants, like that. It should be until it has end. It is finite. And next, infinite set means the elements are infinite. We can take this as x is equals to, the set is equals to integer or natural numbers or whole numbers, like that. And empty set means it doesn't has anything, it is just null set. Empty set is also known as null set. It is just represented by 2 curly brackets without writing anything in it. It is just the empty set. And singleton set means it has only one element. It may be anything, but it has only one element, like 1, 2, 10, any element, only single element. It is known as singleton set. Next, equal set. If 2 sets are equal, if they have same elements. When 2 sets are equal, if they have same elements, then it is equal set. If we can take example as 2, 4, 6. This is one set, and another set is 6, 4, 2. Here order doesn't depend upon this set. We can take any order, or 2, 4, 6, or 6, 4, 2, 4, 2, 6, anything, or ascending order or descending order, or however we can take. But the main important thing is both set should have same elements. That is our main intention to write the equal sets. Next, equivalent set, or next, these 2 sets are equivalent if they have same number of sets. There is a difference between equal set and equivalent set. Equal set means elements should be same, but equivalent set means number of elements should be same in equivalent set, and number of elements should be same in equal set. Equal set should have same elements, and equivalent set should have same number of elements. Here we can take example as, it may be here 1, 2, 3, 4, 5. Here it is one set, and another set it may be like 10, 12, 15, 17. This is another set. It is also different, but these both have same number of elements. So this is equivalent set. If this set also has 1, 2, 3, 5, then this is equal set. If there are same number of, please don't get confused, if there are same number of elements, then it is equivalent set. If it has same elements, then it is equal set. Next, power set. A set of every possible subset. Here about subset, first let's learn about subset. When all elements of set A belong to set B, then A is subset of set B. Here subset means if this is set A, if A is equals to 1, 2, 3, 5, and then B is a set that all should be there. Here 1, Every subset, every set has one null set. So every subset, while counting, we should take every subset has set. We can take 1 2, 1 3, 1 5, or 2 3, 2 5, 3 5, like this. These are the subsets. And null set. Null set is means. Please don't forget about null set, because we take null set also as a subset. And next, power set means a set of every possible subset. From these subset, what is a possible subset again? Then it is sub power set. Next, universal set. Any sets that sets are under consideration. Any set is an universal set. If we take here any subset or any this, if we take this set itself, it is universal set. Only for that set. Again, we can't change like for other sets. Thank you. I think you have got information from this. So please post in the comment box that what is your next class and what is your needs for this paper, and watch the end screen so you get different playlists and videos to find yourself in the different topics, or you can clear your doubts in that. And if you have any doubts, please post in comment so I can see, and please subscribe to our channel, that's Study to IIT. Have a great day.